So, as Daniel said, my name is Joni Collinge and I work at Microsoft. And today, we've got a pop-up, what's that? Ignore that. And today we're going to be talking about reliable and scalable microservices. The aim of this talk is you appreciate microservices, you understand the architectural patterns, but how do you actually get started with these things? Should you be concerned with the networking layer? Should you be getting involved in all that stuff? I'm going to take this kind of in two stages. I'm going to talk about how we approach those problems, and now the services that we're offering to help you bootstrap your adoption of microservices. So can anyone tell me who this man is? Any thoughts? There we go, thanks Daniel. So this is Satya Nadella, and he's the CEO of Microsoft. He's a man that I have a huge amount of respect for two reasons. One, he ultimately signs off my paycheck, and two, because he's a visionary, and he has really transformed Microsoft from what it was 5 years ago. He's turned the company around massively, and allowed us to collaborate with a lot more companies and work in a new, modern way. So Satya has this bold ambition, and we're all on board, that Microsoft is going to empower every person and every organization on the planet to achieve more. That's his standards. I'm just happy if I get a successful build and my unit test passed. So he came over to me, and I was just sat working away, working on this awesome product that was going to revolutionize consumer and server offerings. And over comes Satya, as he does, sits down next to me and goes, "Johnny, I've got this awesome idea. So what are you working on at the moment?" I said, "I'm working on this awesome project. It's called Windows 9. He said, no, forget that. Forget Windows 9. And he says, I've just taken everyone's pension out, and I've bought a load of data centers. I've bought a load of servers. And I'm thinking, so just to kind of caveat there, most people think Windows 9 didn't happen because 789, or what they say is that we have some code out there that is if Windows 9 star or some sort of wildcard. It's not that. Satya came over to me personally and just wiped it out. So we just skipped that and went to 10. So Satya was like, I've bought all these data centers. They're spread across the world. They go from Asia and Australia to South America, all over North America. We've got some in the UK, some in Germany, all over Europe. We've basically got the entire global map covered. We've got more data centers now than Google and AWS combined. I'm thinking, that's great, Satya. Thanks. That's really, really impressive. And then next he pulls out his photo deck, and he's like, these things are big. These things are huge. Like, this is one that we've set up in West US, and he's like, look at the size of this thing. If you look at this lorry, that is a full-size lorry on a highway. You get some sort of reference of size. And this is the size of the expansion. This is over a mile long. This thing is huge, and he's really, really selling it to me. This is big. This is big. And he says, well, I've invested in all this kit. I've got all this infrastructure. Brilliant, we can take over the world. But what I need now is I need software. I need software to run on this. So there I am, scratching my head. And he says, I've got 5 asks. 5 asks of this software. First, it's going to have 99.99% uptime. That is going to be our SLA to our customers, and that's going to be financially backed. So you need to make goddamn sure that this thing runs all the time, 24/7. And he says, well, don't sweat it too much, but you're going to host more than 85% of the Fortune 500. So it's not like there's an economic crisis on your shoulders if this thing goes down. Second, he says, as well as those 85% of Fortune 500, you're going to have millions of customers. And each one of those customers is going to have potentially millions of customers. So this thing is going to be big, and it's going to have to scale. And it needs to be enterprise grade. We need security. We need networking that is resilient to DDoS attacks. And we need security in layers around the data centers, from the user error, from people getting on site, all the way through to massive scale malicious attacks. Oh, went one too far. And then he says, I'd also like this piece of software. It's just a small thing, but can you please make it host every piece of software ever imagined? All right, cheers, Satya. And he says, well, and the last thing, it's only a small thing, this one, but can you make sure that you're pushing at least 1.5 features per day into production? All right, okay. And then he drops the mic and walks off, as he does, with a little smile. And then we're there, sat in front of a whiteboard, scribbling pictures of dragons. So a couple of days later, there we have it. We've built Microsoft Azure. So obviously that is a completely fictitious story. Satya never had that conversation with me, but it gets you the point across that this is a massive scale problem that we had to solve. And Microsoft is traditionally very familiar with machine orchestration. We run SharePoint farms, we run IIS farms, we know how to stand up large-scale server farms. But when you move into this microservices-based world, you need to get away from that. You need to really decouple the services from the underlying infrastructure. There is no longer a one-to-one mapping between your application and the server. So we had to really start to think about service orchestration and how we could approach this problem and solve the problems that you've heard about today. So it really starts with, you have a resource pool, a pool of machines underneath. You then add some sort of clustering technology to that to abstract away all the underlying resources. This tends to be called the data center operating system, the data center kernel, or something along those lines. You then need a scheduler, and you can have multiple schedulers, and this is all about scheduling tasks and how workloads run across those underlying resources. You need leadership election, quorum-based leadership election, to make sure you have an appropriate master that can actually control the consensus across the cluster. And then you need service discovery. No longer are these services going to just be stuck on one box. You cannot say that I know the IP of this service, so I'll just go and ping it. It might not be there when you get to it. It might have moved. So you need service discovery and, or DNS, something like that. Health and service failure. So how can you check the health of the service, health of the machine, and how do you mitigate them, and how do you respond if there is a failure? And finally, efficient scaling. So scaling based on the needs of your service and not necessarily on the needs of the machine. Because you could have one service on one machine that is really, really hot and taking up a lot of resources, and the CPU goes through the roof, and you start scaling out and adding VMs, but actually it just needed redistributing among the other services, and you could have utilized the machines much, much better. So we have taken all of this and we folded it into a project, an internal project that we call Service Fabric. And this is what we used to approach platform services in Azure. So this really is the technology that underlies Cortana. This is the technology that underlies Skype for Business. This is the technology that Power BI, our data visualization platform, sits on. IoT and Event Hub, which are massive scale ingestion engines in the cloud. Our globally distributed NoSQL database, Document DB is hosted on top of this, as well as Azure SQL database. So this is really tried and tested. This has been around for 7-ish years, and we've been working on refining this. And what we've done is we've made it generally available and absolutely free to use. So you're not going to pay for the software, you're not going to pay for the bits. You pay for the runtime. You pay for it running on the machines, the compute usage. So with Service Fabric, you really start with the host. We don't care. Deploy this anywhere. You want to run this in AWS? You want to run this in Google? You want to run it on your on-premise cloud, on your own little boxes sat there? Go and do it. You want to run it, you want to get a first-class experience? You run it in Azure. Then you add on the platform itself. The platform comes in 2 flavors. Supports Windows, also supports Linux. So you can run it on whatever you really want. And then finally, you bring your value. You bring your microservices and host that on top of this platform. Service Fabric takes responsibility for managing all the scale out, the resources, the monitoring, all that stuff is just taken care for you, and you don't have to worry about it. So this is really a fast way to start bootstrapping your adoption of microservices. Where Service Fabric extends the idea of a service orchestrator is that it actually allows your services to integrate with the platform itself. You can query the runtime. You can report custom metrics into the platform to allow it to properly scale based on your services. And I'll dive into that in a little second. So the anatomy of Service Fabric is you take that cluster and you install the bits. If you're in Azure, we'll do that for you. We have something called Azure Resource Manager templates, so we can install all those bits onto the boxes for you absolutely fine. If you're going to run it in AWS or something like that, it's your responsibility to get those bits on the boxes. And then you have system services. These system services actually sit on the box as services next to your own services. So no longer have you got a master sat outside orchestrating the cluster, you've actually got what they call choreography, where the services sit inside the cluster. That allows you to get rid of all those extra boxes that you're hosting, and it also allows you to get around network issues where you might actually have a master outside of a firewall, etc. So you have multiple versions of these system services for high availability and high resilience. So you've got fault analysis, failover, cluster manager, and a naming service which does service discovery. These nodes are hosted on what we call VM scale sets, which means you can define multiple VM scale sets for different services. So they can scale out infinitely in in separation. So you could also have a front-end VM scale set, which are low-power machines, which you want to scale out massively. And then you could have a back-end VM scale set, which scales out independent of the front one, but has higher-powered machines inside it. And for instance here, I've just taken a web UI, said I'm going to have 9 copies of that and spread that across the cluster. A registration service, you've got 3 of them because it's actually a stateful service, and that's something I'm going to discuss in a second. Same with the billing service, and finally the notification service, which is just going to have 1 instance. So I'm just going to quickly show you what the dashboard for this looks like and how working with it feels. So this is the dashboard into, oh, no it's not. Let's make sure I'm duplicating. 2 seconds. So this is the dashboard. Awesome. So I've got Service Fabric running on my Surface Pro because there's a dev experience. You can actually run the cluster on your machine. And it runs the exact same bits that would be spread across a cluster normally. That's why the fan is going mental on my Surface Pro 3. So at the moment, I've got a 5-node cluster. Obviously, I don't have 5 nodes. That's emulated kind of on my machine, and it currently has 1 application on top of it. So if I quickly just dig into the applications here, you'll see that I've got this drone type. Oh, actually, it's not fully loaded. Here we go. So there are my services. So I have an application which is called drones, and inside of it, I have 7 microservices that I've created. Inside of them, I then have different, what we call partitions. And each of these partitions has 3 replicas for high availability and high resilience. So this way, we can actually make sure that whatever happens, if there's failures, multiple failures, your services will stay available. And then you can also see that they've moved this down here. These are the system services which I highlighted before, running within the cluster as well. So you've got the naming service, et cetera, et cetera. And these things are very, very resilient. So you'll see that there's actually 5 different instances and 3 different replicas of the naming service. This thing would take a while to take out. You'd have to take down the whole cluster for this thing to go down. So just quickly jump back to this. So when you approach Service Fabric, we give you 3 methods of adopting this. The first one is guest executables, or what we call guest executables. And this is really, I'm guessing that's not planned. Just wait it out. It'll be fine. Unless Daniel comes running in or I smell smoke, we'll be fine. I'll just try and talk through it. So guest executables is all about bringing your own executables, your own processes that you've already got. You don't have to change any code. All you do is repackage it as a Service Fabric application and then host it on Service Fabric. And that just gives you the high reliability, high scalability out the box. You don't have to change anything about what your code does. Then if you want to adopt some more of the native integrated platform services, then you'd step up to what we call reliable services. This comes in 2 flavors. Reliable stateless services, which is just a stateless service which can integrate with the fabric, so you can report your custom metrics, you can query the metrics, you can see what node you're on, you can see where everyone else is, you can influence the decisions that are made by the fabric. But it's completely stateless. There's no idea of state in there. You'd probably store your state off in SQL database or in blob storage or wherever you're going to store that in S3 or whatever. However, we also have stateful reliable services. What that allows you to do is actually store state in the service itself, which is highly available and highly distributed across your cluster. And I'll show you how that works very briefly in a second. And then we have the highest level of abstraction, which is reliable actors. So how many of you guys are familiar with the actor model, actor programming model? There's 1, 2, 3. Okay, so not that many. So the actor programming model is a way of basically simplifying working with distributed systems. So when you think about it, okay, I've got a service A over here and service B over here. Bit weird, there. And they need to talk to each other. They need to make a remote call to the other one. You'll have to find out where that service is. You have to find the endpoint. You have to serialize the data you want to send across. And then you'll have to inspect the interface to make sure you're calling the right method. And then you've got to make the call. And there's all of this kind of glue and all of this plumbing which you have to do. The actor model abstracts that away from you, so you just literally make an RPC call. And it just feels like you're almost talking to another object within the same binary, but you're not. And there is some other benefits to it as well as some quirks. So how does this look? Well, this is the code for working with a reliable service. So what it actually does is it gives you data constructs. So it gives you a dictionary, which we call a reliable dictionary, and a reliable queue. And this is C# code, and there is Java SDK as well, and there's going to be more rolled out, such as JavaScript for Node and etc. But basically, you talk to this state manager, and this state manager is responsible for your stateful service's state. And you ask it for a reliable dictionary of the identifier, my dictionary. Guys, get your minds out of the gutter. So anyway, so you get that back and you've got your reliable dictionary, and you just work with it very, very similar to how you would work with a normal dictionary or a normal queue or a list or whatever data structure you would use normally in programming. The difference is you take a transaction out, like here where it says start of transaction, I create a transaction. I then take my reliable dictionary and I add a key to it, a key and a value, which is just hello world in this case because it's a string, and then I commit that transaction. As soon as that commit returns, like commit async, as soon as that returns, that has been replicated to a quorum of clusters or services across the cluster. So that state is saved. So as soon as that returns, if this service fails, it doesn't matter. That data is still stored within the cluster and is available to any of the other services. So this is a way of actually getting rid of maybe some external storage. For hot data and things, you no longer have to go and store it in an external store. You can actually keep it on the box with the code. So you're getting true stateful services, which are highly available and highly scalable. And then we step up to, it keeps taking a while. All right, let's go to reliable actors. We step up to reliable actors. So this is that simplified model that I was talking about. So in this case, I just get a sensor ID. I talk to this actor proxy static method called create, give it the actor ID, and I get an actor back. And then I can just call methods on that actor. And I don't need to worry about the state, because the state is handled for me. I just say, my sensor.publish value. That goes and does something, all the state is changed. If I change a property on that actor, the state is saved. You don't have to worry about all that, it's just done for you. So it's a very, very simple way of working. And it maps very nicely to something like IoT, where you might need compute and state stored together, working at high scale, because these things can scale out to millions and millions of instances. So we kind of built our own sort of containers when we were thinking of making Service Fabric, and that was because it was going to run on Windows, and it was going to run with Windows processes, and things like Docker hadn't really matured yet. We're kind of now retrofitting Docker support back into Service Fabric. So when Windows Server 2016 actually goes live with Docker support on Windows, and I'll talk a little bit about that in a second, we will be able to run containers in Service Fabric. That will come in two flavors. Guest containers, that just means you point it to your hosted Docker image, so that could be in Docker Hub or in Key.io or wherever, or a private repository, and you say, this is my container, Service Fabric will pull that down, instantiate it, and host it. Simple. Native containers really is just packaging those reliable services and reliable actors as Docker containers and hosting them within the service. But at Microsoft, we need to be open. No man is an island. We need to know what people are doing and meet the developers where they are. So there's a couple of stats for you. So 33% of all virtual machines running on top of Microsoft Azure today are Linux-based virtual machines. 76, and this is according to open source tech survey, 76% of you guys, of software vendors, are going to be experimenting with containers in the next year. And finally, 85% of you guys are already already have adopted open source technologies in some form or another in your toolchain and in your systems. So we at Microsoft have partnered with a lot of open source market leaders, really, and this is really just a small subset of them, but we are working with Ubuntu to bring you Bash and Ubuntu basically on Windows. So how many of you guys have played around with Bash on Windows? 10? There's a couple, but that's we're running a Linux subsystem on our Windows, on Windows desktop. That's pretty impressive. We're working with Docker, and I'll talk about what we're doing with them. We're working with the Linux Foundation, Red Hat to bring you, fully supported Red Hat offerings, OpenStack offerings, and RHEL offerings in Azure. And we're working with Mesosphere, and again, I'll talk about that in a second, about what we're doing with them. So Mesosphere has a fully supported DCOS instance that is out of the box on Azure today. You can go into Azure and you can say new DCOS and create your cluster supported with Mesos in there, already pre-configured, with all of the stuff that you need from the enterprise-grade Mesosphere offering. So you're not just starting with Mesos and then working, all right, how do I do service discovery? How do I do scheduling? What schedulers do I need? You can just do this out of the box and change a few configuration files around, and you can have Kronos running on this. You could have Hadoop, whatever you want to, schedules and applications you want to run on this, you can do that. So that's very, very simple. And we're working very closely with Mesosphere on this. We're actually part of the DCOS project, which is an open project. Next, Docker. If Docker is your flavor and you want to use a full Docker stack, Docker Data Center is a fully managed managed service on Azure today. You want to work with Docker Swarm and you get added security where you get signed containers and you've got trusted registry of containers along with their universal control plane management service that they offer. You can do that. And again, one-click deploy. Go and do that today. Docker Cloud, anyone played with Docker Cloud? No? So Docker Cloud is a complete Docker offering. It's got nothing to do with Azure other than you can host it on Azure. So you just change the provider to AWS or Azure or Cloud Foundry or wherever you want to host it, and you just do that out of the box. And then we've got our own offering, and I know this feels like, okay, you're repeating yourself now, but this one is completely supported by Microsoft. So this is a Microsoft product team that are doing this. It's not Mesosphere, it's not Docker. This is our own thing where we are using their technologies to build a container service. This is Azure Container Service. Oh, and yeah, that supports Docker Swarm or Mesosphere DCOS. You can actually pick the orchestrator in that. It's just a config switch. But do you know what? I really don't care what you want to run. You want to run Kubernetes? Absolutely go and do that. Run Cloud Foundry, Rancher, CoreOS, OpenStack. You name it, you can run it. Because all these things are, and ultimately, is virtual machines at the base. And then we give you higher level abstractions that allow you to configure these things and add what you want in there out of the box. So very, very simple. So this is what I call the Azure Compute Continuum. So just get a quick raise of hands. How many people are using Azure? Oh God, so there's a fair few. All right, so how many people are using AWS at the moment, and the rest, anyone using Google? No? All right, fair enough. Okay, so this is the compute continuum for Azure, and down the far end we've got the very, very bare metal, well not bare metal, but the very low end of the IaaS spectrum, and at the top we've got our platform as a service offerings. So VMs at the bottom, everyone knows what a VM is. You go and instantiate and provision a VM. We then have VM scale sets, which I briefly mentioned what they are. They're a way of basically stamping out virtual machines or clones of virtual machines to a scale that you define. So you could say that, based on CPU, I want to scale these up to 100 VMs. You can absolutely do that. VM extensions, that's just basically a VM with some pre-baked scripts that run on startup. And then we've got Azure Container Service, which I've mentioned what that is. That is basically our own product that we're working on, which harnesses Docker Swarm and Mesosphere DCOS. And then we've got Service Fabric. And Service Fabric, again, I kind of mentioned what that is. That is our what we call V2 Platform as a Service. It's not quite V2 Platform as a Service, but it is something that you can take, get elastic compute, high scalability, data persistence, and host it wherever the hell you want. As I say, host that in AWS, host that in Google, Azure, on-prem, whatever. Use the languages that you want to use the protocols you want to use out of the box. We then have App Service. So is anyone using App Service today? Those guys who are using Azure, just the one. I'd say App Service is our most compelling offering. And really, you get rid of the need to know about containers. You get rid of the need to know about virtual machines and all that stuff. All you need to care about is running a website or a mobile backend or whatever it is. You just care about the package or the artifact for your web server. So if it's Node, then you just take the Node.js, whatever it is, and chuck it up there. If it's ASP.NET, you just throw up your package using web deploy. And that's all you need to care about. And then I think Michael mentioned it earlier, we have Azure Functions, which is that serverless offering. So that is, something happens. Someone has dropped a file in storage. Something has gone on a queue. Something has happened that's triggered, or a webhook or whatever, has triggered a bit of compute. You just give it a few lines of code, and that will run when that is triggered. And that's all you need to care about. You really just don't need to care about, what web server it's running or any of that stuff. You just care about that tiny little bit of code. And that is great for knitting things together. It's very, very compelling when you need to just run a bit of code in response to something, to maybe move something to a new queue or whatever it is. So Windows Server, is that getting any love as well? So we're all familiar with Docker on Linux. I mean, there's been conversations today about containers and how they work. Really, it's about isolating your dependencies and getting higher density on your virtual machines. And these things share the Linux kernel. The Linux kernel is a very stable API, which means that you could have Ubuntu, you could have CentOS sat next to it, you can have other distributions of Linux sat next to it, and they just share the Linux kernel because they all have that in common. We've been working with Docker to bring this to Windows Server so that you get the exact same experience on Windows as you would on Linux when working with the Docker tooling. And we've gone a step further, and we've brought Docker on Hyper-V. So there's a lot of, especially when you're speaking to enterprises, people are worried about the security and the true isolation of containers. They think that what happens if a process or a malicious process leaks outside of my container? There's a shared kernel. What happens if something gets into that kernel and changes some of those libraries or changes something, how something works, which affects my code? And if I'm hosting this in the cloud on shared infrastructure, how the hell are you going to mitigate that? How are you going to stop that? And that's where Hyper-V comes in, where we wrap the container in a very, very, very thin layer of virtualization. That means if your process or a process gets outside the container, it just gets into that Hyper-V layer. It doesn't get into the shared kernel. So that, at the cost of a couple of milliseconds of performance, you actually get a higher level of security and isolation. So I'm just going to quickly show the Docker experience just to show you that it's identical to what you would normally expect. So this is killing my back, but so I'm just RDP'd into a virtual machine hosted on Azure. I'm not here to show you how the Docker interface works, so I'm just going to show you that these commands run exactly as you would expect if you were running on a Linux box. So at the moment you can see that I've got 3 images there. I've got Nanoserver, which is only 800 meg. Sorry? Oh god, it is fairly small, isn't it? Jesus. Good shout. Okay. Yeah, I'm trying, but come on. RDP taking its time. Okay, here we go. All right. Now, there is something scary here, and that's the size of this thing, and we're trying to investigate that at the moment. But Nanoserver, which I'll talk about shortly, is kind of the server that we need to be working with in this space if you're going to be working in the container world. So at the moment, I am running no Docker containers. I'm just going to quickly run up an IIS container. So when that starts, hopefully it doesn't take too long. Okay. So now, as you can see, Cranky Hamilton, I love how Docker does this, it's brilliant. Cranky Hamilton is now running, and if I just quickly, I'm just going to inspect the network so I can get the IP address. Control-C that. Jump into IE, everyone's favorite web browser. You have to HTTP. Right, there you go. You've got an IIS server up and running out the box in a container on Windows Server 2016. So the experience from a developer's point of view is identical to that as the experience on Linux. And then bringing that where we can wrap that in a Hyper-V container and use something like Nanoserver where you're talking order of magnitude of a couple of 100 megabytes. It's a very compelling story to use containers today, or when it releases, on top of Windows as an alternative to Linux. So let me just jump back. All right, so just to kind of cover that again, what is the story around this? Well, Windows Server 2016 is our full fat server. You get the GUI, you get the desktop, you get all the services installed as default. You want an enterprise grade service with IIS and all these things that you just expect out of the box. That's Windows Server 2016. We've then stripped that down to the very kind of core essentials that you might need to run a service, and we call that Windows Server Core, and that's about 1/3 of the size of Windows Server 2016. We've taken that then a little bit further to Nanoserver. Nanoserver only has a 64-bit address space. It has no desktop, no GUI. It has to be completely remotely managed, so you can't actually get onto the box. There's no SSH or anything like that unless you install it and then use it. And that can run in roughly 400 megabytes of memory. So now you're kind of getting to a very, very small server that's very flexible, almost at the, if anyone's a Linux developer, like what we do with BusyBox or something like that, you're actually talking about very, very lightweight servers as well as very, very lightweight containers on top of these things, because you can run containers on top of Nanoserver or whatever you want, which is great. And it's coming slowly. We're in technical preview 5 at the moment, so hopefully within the next few months we'll have something more concrete there. So that makes Satya very, very happy, and that's a tick in the box, because we have provided that high scalability, that high reliability, the agility, because we are publishing 500 new features into production every year. We are scaling to millions of customers. We are keeping that SLA, and if we're not, and if you guys, the ones that are using it, have found that the services are down, when that should be financially backed, you should definitely follow that up with any with your SLAs that you have agreed with Microsoft. So we're meeting those, and it's only going to get better from this point onwards. So just to kind of, my call to action is anyone who's interested in Azure documentation, please do go to aka.ms/Azure Docs. If you're interested in the Windows container story and what we're doing around containers and how you can get started running containers on Windows Server today and on Windows Desktop, please do go to aka.ms/containers. I blog about this stuff. I blog about design patterns and things on how to work with Service Fabric if you're interested in that and some of the container stuff. So my blog is .json.uk. And again, Twitter, if you hadn't noticed it in the top corner all throughout this presentation, is @.json. So just to cover what we have said, we've talked about Microsoft Azure and what that is and how we approached moving from a very much server farm to a service orchestration to a service choreography architecture. We've talked about Service Fabric and what that is and how you guys can leverage that today, and if you want to. And if anyone wants to see any of this demo, please do come to the stand. Me and Marcus, the guy at the back there, will be covering this stuff, demoing whatever you want. Just come and speak to us. Talk about third-party services and the innovation that we're doing around Windows Server. So thank you very much for your time. Thank you. Oh, well, yeah, have you got any questions right now before I wander off, sneak off? No, speechless. Love it. Love it, love it, love it. Well, if you do have any questions or anything you want to see in live action, you want to see us spin up some cluster services or whatever, come and find us at the stand. We're there all day.